Hey, all your friends, let's see this question of kinematics from Pathfinder. It's a build up your understanding question number 36. So as you can see in your screen, the question states the load A is being pulled up with the help of two inextensible strings that pass over two fixed pulleys as shown in the figure here. At an instant, velocities of the end of the string being pulled are u1 and u2, and the angle between the strings connected to the load is theta. What is the speed of that load? So this is a question of a string constant involving fixed pulleys, and obviously the strings are inextensible. So we will use the important result that in this case where the pulleys are fixed and the strings are inextensible, the component of the resultant velocity of all points of the string along the length are same. So using that result, we will get the desired answer. So let me go to the next page. The same diagram. These two ends are being pulled with the velocities u1, u2, and angle between the strings is theta, and we have to find the velocity of F. So if u1 and u2 were same, so the situation would have been symmetric. And in that case, these string would make the same angle from the vertical. So, right, and in that case, A would go vertically upward. Now u1 and u2 are in general different, so A may not go vertical, A can go along in any direction. So suppose, let me assume that A is going like this. The velocity of A is say V, and that's what we have to find. So let me take this blue color string. This string will always be vertical, but it will go like this with the velocity of A. So all point of this string at any moment will have the same velocity at a particular moment, same velocity. At this moment, all point of that blue color string will have the velocity A, velocity V. So this end of the string will also have the same velocity. Suppose this velocity is V. And suppose this end of the string here, I want to apply the string constant on this string first, and suppose this velocity makes some angle, say this angle is say phi from this string. So applying the result, component of the resultant velocity of any point along the length are same. So this point has a velocity v, and I'm talking about this string, so velocity of this point of this string along the length is v cos phi, and the velocity of this point of this string along the length is u1. So first equation is v cos phi is u1. That is my first equation. So cos phi is equal to u1 by v. So I may need sin phi later. So sin phi is equal to square root of 1 minus cos square phi. So sin phi, putting the value of this cos phi here, so that we will get square root of v square minus u1 square by v. So that is the second equation. And same way, I will apply the constant equation on this string. This whole angle is theta, this angle is phi, so this angle would be how much? Theta minus phi. So component of the velocity of this point of this string along this length, that will be v cos theta minus phi. And the component of the velocity along this string, along this point of the string along the length is obviously u2. So another equation would be v cos theta minus phi is equal to u2. That is my third equation. These are sufficient tool to just I have to eliminate phi. So let me go to the next page. Rewriting that equation, v cos theta minus phi is equal to u2. Just this, expand cos theta minus phi. So that will be cos v cos theta into cos phi plus v sine theta into sine phi, and that is equal to u2. From here, v cos phi is equal to u1 I will use. So v cos phi is equal to u1. So here in place of this, I will write u1, and then that is a cos theta plus v sine phi, v sine theta. In place of this sine phi, I've calculated before sine phi, equation 2. In place of sine phi, I will write square root of v square minus u1 square by v. So writing it here. And this is equal to u2. So this v and this v will get cancelled. So now just some simplifications. V square minus u1 square is equal to, and obviously that sine theta is also multiplied, so I will take on that side. So u2 minus u1 cos theta by sine theta. Square both sides. So v square minus u1 square is equal to u2 square plus u1 square cos square theta minus 2 u1 u2 cos theta by sine square theta. So I want to take that u1 square on that side. So if I take here, so here itself, what I can do, I can just equate this and make this plus. And if I take the sine square theta as LCM, I'm doing all in the same step here. So if I take sine square theta as LCM, so there sine square theta will also come. So now you can see here on this part, and this part, you can take u1 square common. So that will be just u1 square sine square theta plus cos square theta is equal to 1. So that will become u1 square plus u2 square minus 2 u1 u2 cos theta by sine square theta. You can write in the next page. So v square would become u1 square plus u2 square minus 2 u1 u2 cos theta and divided by sine square theta. So we got the answer finally. So v is the square root of u1 square plus u2 square minus 2 u1 u2 cos theta divided by sine theta. This is final answer.